Right, these are our notes on volume. Volume is the amount of space an object takes up. The base unit of volume in the metric system is the liter. And it's represented with the capital L or the lowercase l. 1 liter is equal to 1 cubic decimeter. Okay, metric units that you need to be familiar with. That 1 liter is equal to 1,000 milliliters. 1 milliliter, and that's measuring in liquids, because we're dealing with liters, is equal to 1 centimeter, which is dealing with solids. So anytime that we're measuring a solid, we should have the unit being cubic centimeters. And that's also equal to 1 gram. To be able to measure volume, if we're dealing with liquids, we'll be using a graduated cylinder. To use a graduated cylinder, you're going to measure based on the bottom of the meniscus, okay, or the curve in the water. Okay? And you're also going to get down at eye level so you can see where the bottom of that curve hits on the graduated cylinder. So looking at this picture, and it's zoomed in on it, how many milliliters are in that graduated cylinder? Well, if we look at it, it's marked by tens, and it's counting by ones. So it's 41, 42, and 43 hits right on that meniscus. So there's 43 milliliters in that graduated cylinder. And what causes the meniscus? The meniscus is caused because the molecules of the liquid are attracted to the molecules in the container. So the glass attracts the water to the sides, causing it to dip down in the middle. Okay, we're going to do a couple examples here where you're reading a graduated cylinder and finding the volume. Okay, looking at graduated cylinder A, it's marked by tens, so that means it's counting by ones. So we've got 51, 50, 55, 56, 57, 58 milliliters in cylinder A. For cylinder B, I want you to try reading cylinder B on your own and see what you come up with. For cylinder B, it's a little tricky because of the way that it's marked. It's marked by ones, like it's counting by ones. So the little lines in between are actually going by tenths. So it's 3, 3.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. So 3.7 milliliters in graduated cylinder B. Then go ahead and look at cylinder C and see if you can figure out how many milliliters are in that graduated cylinder. Okay, looking at this, we've got 70, 71, 72, 73 milliliters. Okay, so that's how we use a graduated cylinder to measure volume. When we're measuring with solid objects and they're rectangular prisms, we're going to use the equation length times width times height. Okay, so we're using length times width times height. So our length on this rectangular prism is 10 centimeters. We usually say the length is the longer side. Okay? The width is 8 centimeters. And the height of the rectangular prism is 9 centimeters. So to calculate the volume, we're going to take those numbers and multiply them together. Okay, so starting with 10 times 8 gives us 80. And then 80 times 9, 9 times 0, 0. 8 times 9 is 72. So we have 720 centimeters cubed. Okay, remember I said when we're measuring a volume of a solid, it's centimeters cubed. Okay, so that's our volume. And it's always got the 3, the exponent of a 3, because we're multiplying 3 units of centimeters together. So that's why it's a cube, and it's a 3-dimensional figure. Okay? All right, going over to the back side of the paper. Now we're looking at irregular shaped objects. Okay, to be able to find the volume of shapes that are not rectangular prisms, we're going to need to use the displacement method. Okay, and when we're using the displacement method, we're going to be using graduated cylinders. So what you'll do is you'll look at the graduated cylinder after you've poured in some water or liquid, and you're going to read the amount of liquid on the graduated cylinder. So for this one, the initial volume, before we add anything into it, is 200 milliliters. Okay, so that's V1, the first volume, or volume 1. The final volume, so the volume after we've put the object in, is 300 milliliters. Okay, to calculate the volume of the solid object that we put inside, we need to subtract or find the difference of the initial volume and the final volume. So we're taking 300 minus 200 to give us